Good morning to all of you. Today, our subject is mechanics of solid. Last class, I will discuss what is the point of contraflexure. Point of contraflexure. Clear? Today, I will do some problems in point of contraflexure. Now, this is problem number 65. 65. The question is, a beam ABC carries udal of 2 Newton per meter over center length 3 meter and a point load 1 Newton at its free end C. Draw the SFBM diagram and find the point of contraflexure. Clear? The question is, a beam ABC of 3 meter long carries udal of 2 Newton per meter over length of over its entire span and carries a point load of 1 Newton at its free end. Draw the SF and BM diagram. For the beam and locate the point of contraflexure. Clear? This is question number 65. The question is, a beam ABC 3 meter long carries udal of 2 Newton per meter over center span and carries a point load 2 Newton at its free end. Draw the SFBM diagram and locate the point of contraflexure. First, find the reactant A and the reactant B. Let this RA, this RB, right? Let RA is equal to reactant A, RB is equal to reactant B, right? Sigma Y0, Y is equal to 0. RA plus RB is equal to 1 plus 2 into 3. This is 2 Newton per meter. This is 2 into 3 Newton. This is 3 by 2 meter. And this is 3 by 2 meter. half of this length. Total load is W into L ejecting at L by 2. Now, sigma y 6. This is equal to 6. Now, RA plus RB is equal to 6 plus 1, 7. Right? RA plus RB is equal to 6 plus 1, 7. Take mounted A. This is equation 1. Sigma MA is 0. MA is 0. About A, RA passes about A. So its movement 0. Clear? So RB into this, W into this. Clear? RB into 2, 1 into 3, plus this, plus 6 into, plus 6 into 3 by 2, 2 into 3 into 3 by 2. Clear? Now, three, so RB into 3, 2 is equal to 3 plus 9, 12. What is RB is equal to? 6 Newton. 6 Newton. Clear? Now, what is RA? From question 1, RA plus RB is 7. RA plus RB is equal to 7. Clear? What is RA is equal to? 7 minus RB, 7 minus 6 is equal to 1 Newton. RA is 1 Newton, RB is equal to 6 Newton. Clear? Now we'll find out the shear force at the point A, at B and at C. Then draw the shear force diagram. Then make calculation for bending moment. Then draw bending moment diagram. Then you see the point where the bending moment changes sign from negative to positive or positive to negative. That point is called point of contact flexure. Then I will find that point P. Clear? Now step calculation. So RB is equal to 6 Newton, RA is equal to 1 Newton. Clear? Now shear force calculation. Step calculation. Now, shear force calculation. At C right, C left, B right, B left, A right, A left. Clear? Shear force at C just right. Shear force at C just right. Just right. 0. Clear? Just left. Shear force at C just left 1 Newton. Right downward positive. Next, B. Shear force at B just right. B just right. 1 plus 2 into 1. 3 Newton. Clear? B just left. Shear force at B just left. 3 minus RB. 3 minus 6 minus 3 Newton. Clear? 3 minus 6 minus 3 Newton. Shear force at A. Shear force at A just right. Minus 3 plus 2 into 2. 1 Newton. At A right. At A left. Shear force at A just left. 1 minus 1. 0. 0. Clear? Now, A A B C. Scale 1 sim 1 is to 1 means 1 same 1 Newton. Scale 1 same is equal to 1 Newton. Clear? Shear force at A, she just right 0. She just right 0. She just left 1 Newton. B just right 3 Newton. Three Newton. B just left minus 3 Newton. A just right 1 Newton. A just left 0. Clear? This is 0, 1 Newton, 3 Newton, minus 3 Newton. Clear? 1 Newton, 0. Right? Now, positive, negative, positive. A, B, this is point D. This point D or M. At point M, the shear force changes sign. So at this point, the bending moment will be maximum. So first find out this point is M. Suppose the distance x. What is this? 1 minus x. 2 minus x. 2 minus x. Now this is point x. BM calculation. At point M, this point M, and also point B. So at both points, bending moment becomes maximum. At point B, bending moment maximum. At point M, bending moment maximum. So B point is 1 meter from C. M point is x meter from A. So find out what is below x. At point M, the shear force changes its sign. So, and also at point B, the shear force changes its sign. Clear? At M and at B, at both these points, the BM is maximum. It may be positive maximum or negative side maximum. Clear? At these 2 points, the BM is maximum. BM is maximum. Clear? First find out the point M, where the point M lies. The point M lies distance x from A. Clear? First find out what is the value of x. From figure x by 1 is equal to 2 minus x by 3. Clear? So make a cross multiplication. So 3x is equal to 2 minus x. So 4x is equal to 2. What is x is equal to? 2 by 4, 1 by 2, 0.5 meter. Clear? This is 0.5 meter. This is 1.5 meter. 1.5 meter. Now, first make a bending moment calculation. Now make calculation for bending moment. At C, DM at C 0. Clear? At B, BM at B B 1 to 1 minus 2 into 1 to 1 by 2. At B, this is 1 Newton, this is 2 into 1, 2 Newton, this is 1 by 2, 1 by 2. Clear? So 1 plus 2 into 1 into 1 by 2. Both are negative, both are downwards, both are negative. So minus 1 into 1 plus 2 into 1 into 1 by 2 is equal to minus 1 plus 1 minus 2 Newton meter. Clear? Next, at M, BM at N, at M, this x 1 x minus this 2 x into x by 2. Clear? 1 x minus 2 into x by 2. What is x by 2? 0.5 x square. This is x square. X minus 1 x means 0.5 minus 0.5 into 0.5 is equal to 0.5 minus 0.25 minus plus 0.25 Newton meter. Clear? 0.25 Newton meter. When you wanted M is equal to. Next, at A 0, BM at A 0. A is equal to 0. Right? Now Draw the BM diagram. BM diagram. A, M, B, C. Take scale 171 Newton meter. Scale 1 same is equal to 1 Newton meter. Clear? At C0, C0. Clear? A, M, B, C. Right? At C, BM is 0, C 0. At B, minus 2 Newton meter, minus 2 Newton meter. At M, 0.25, 0.25. At A, 0, 0. Right? So, first we'll draw the bending moment diagram. This is B to C to B. This is A to M. This is all are parabolic. Clear? So all are parabolic curve. This is point P. Point P. Point P, the BM changes sign from positive to negative. This is positive value. This is negative value. Clear? So at this point, the bending moment changes its sign from positive to negative, from negative to positive. So this point is called point of contact flexure. We will find out the P, where P lies, or locate below, locate the point P. Let this is Y. Suppose this is Y. This is equal to Y. So find what is the value of Y. And at P, the BM is 0 because A 0, M 0.25 Newton meter, P 0, B 2 Newton meter, C 0. So first find out the moment at P equal to 0, we will find out the value of Y. Clear? The bending moment changes sign. The bending moment changes its sign from positive to negative, from positive to negative at point P. Point P. Clear? This point P is called, this point P is called point of contrafracture. Point of contrafracture. Clear? This point P is a distance y from A. Let y is equal to let y is equal to distance of P from A. From A. Clear? Now find value of y. Value of y. Now BM at y, BM at P is point P. Point P. Clear? Distance y, for this load 2 into y Newton. For this length 1/2. This is y/2. Clear? Find the bending moment P equal to 0. Now BM at P is 0. Clear? This is what is P? Bending moment P 1 into y minus 2 into y into y/2. 1 into y minus 2 into y into y/2. 0. Clear? 2 to cancel out. So y minus y square 0. So y into 1 minus y 0. What y is equal to 0. 1 minus y is 0. Same place y 1 meter. This is control y 1 meter. Right? Now at this point P, bend node 0. This point P is 1 meter from A. Clear? This is our problem regarding point of contrafracture. Now next question I will do question number 66. 66. Very important question. These are very important questions. Now, this is question number 66. Another question for point of contraflexure. The topic is point of contraflexure. The question is ACDB beam ACDB loaded and supported as on figure. Draw the shear force bending moment diagram for the beam. Locate the point of contraflexure and where the maximum bending moment occurs. Clear? Now, first find out the reaction at A and the reaction at B. First find out the reaction at A, reaction at B, then shear force calculation, then bending moment calculation. Right? This is RA, this is RB. Question is the beam ACDB is loaded as on figure. As on figure. Draw the SF and BM diagram. SF and BM diagram for the beam. For the beam. Clear? Now, to make solution, let RA is equal to reaction at A, RB is equal to reaction at B. Now, sigma y 0. RA plus RB is equal to this 1005 plus 8000 plus 4000 plus 1600 into 2.5. Clear? This is 1000 into 5000 Newton. This is 5/2. This is 5/2. Clear? This is 1600 into 2.5 Newton. 1600 2.5. Value is 4000. Clear? 4000 Newton. This is 2.5/2. This is 2.5/2. Now, RA plus RB is equal to The 5,000, this is 4,000. Clear? 5 plus 8, 13 plus 8, 21. 21,000 Newton equation 1. Clear? 18, 5 plus 8, 13 plus 4, 17 plus 4, 21,000 Newton. This equals 1. Next, take amount of day. Sigma m is 0. ma is equal to 0. About a RA passes about point A, its moment 0. Clear? What is RB into this? RB into 5 plus 5 plus 2.5, 12.5. RB into 12.5 is equal to 5 into 5 by 2. 5,000 into 5 by 2 plus 8,000 into 5 plus 4,000 into 7.5 plus 4,000 into this. What is this? 5 plus 2.5 plus 5 plus 1.25. Clear? 5 by 10 plus 2 and 13.75. Clear? So find RB. Find RB. Now RB is equal to 11,000 Newton. 11,000 Newton. From equation 1, RA is equal to 21 minus RB, 10,000 Newton. 10,000 Newton. Right? Now make shear force calculation. Clear? I have already found reaction A, reaction B. All loads are given in the question. Now we will find shear force at all the points. Value of shear force at all the points. This is RA, this is RB. What is RB is equal to? 11,000 Newton. What is RA is equal to? 10,000 Newton. Right? Now shear force calculation. At B, at E, 0. Shear force at E, 0. This point E. At this point, shear force 0 because to right of the E, no force. At E, shear force 0. Clear? At B, just right. Shear force at B, just right. This 2 into 1600 into 2.5 means 4000 Newton. 1600 into 2.5, 4000 Newton. Clear? B left. Shear force at B, just left. 4000 minus 11,000 minus 7,000 Newton. B just left. Clear? The D just right. Shear force at D just right is equal to minus 7,000 Newton. D just right. Only minus 7,000 Newton. Clear? Because between D right, B left no load. So D left means D right. At B left, D left. Shear force at D just left. Minus 7,000 plus 4,000 minus 3,000 Newton. D just left. C right. D just left, C right. Same. Shear force at C just right. Minus 3,000 Newton. Then C left. Shear force at C just left. C just left. Minus 3 plus this. What is this C? 8,000. Clear? Plus 5,000 Newton. C left. A right. Shear force at A just right. 5,000 plus 5,000. 1,000 to 5. 10,000 Newton. C left 5,000 plus this is 5,000. 1,005. Right? 10,000 Newton. A left. Shear force at A just left. 10,000 minus 10,000. 0. 0. Clear? Now, draw the shear force diagram. Clear? A, C, D, B, P. ACDB. Right? Now, scale 1 stimuli 1000 Newton. Take scale 1 stimuli 1000 Newton. 1000 Newton. Right? Now, at E0, B just right 4000 plus 4000 Newton plus. B just left minus 7000 minus 7000. Clear? D just right minus 7000 Newton. Clear? G lost left minus 3000. Right? She just right minus 3000. She just left plus 5000. H just right 10,000. H just left 0. Clear? 0. Now join all the points. These are points from E to A. Join all the points. Then we will complete the shear flow diagram. First, from 0 to 4000 plus. Next, 7000 minus, then 7000 minus, then 3000 minus. Clear? Again, at C right 3000 minus, at C left 5000 plus, at A right 10,000 plus, at A left 0. Clear? Now we will draw the bending moment diagram. After calculation bending moment draw all the points. So here the shear force changes sign C and B. These 2 points, the bending moment is maximum. Clear? At C the bending moment maximum, at B the bending moment maximum. One of them may be positive or one may be negative, but one may be positive side of maximum value, one may be negative side maximum value. But at this point the BM is maximum. Now find the value of BM at A, B, C, D. Now Now we will do bending mode calculation. BM calculation. It is 0. BM at E 0. Because before there is no force, it is equal to 0. At B, is equal to minus 4000 into 2.582. Clear? Minus or 1600 into 2.5 minus 1600 into 2.5 into 2.582. Clear? This is 1600 into 2.5 to 2.82. This is 3000 Newton minus 5000 Newton. This is minus 5000 Newton meter. A D, BM at a D. A D, this plus, this is minus, this is plus. So 4000 into, this is 2.582, 1.25. Clear? So minus 4000 into 2.5 plus 5 plus 2.52, 5 plus 2.52 plus R into this. R means 11,000. 11,000 into 11,000 into 5. Clear? So the answer is 3000 Newton meter. 3000 Newton meter. Clear? 30,000 Newton meter. 11,000 into 5, 55,000. This is 25,000. 5 plus 1.5, 1.25 into 4,000. Clear? 6.5 into 4. 6.25 into 4. 25. So 25 minus 55 plus 30,000 Newton meter. Next, let's see at a C. This is point C. So this point C come from left. 10,000 into 5 minus this into this. 5,000 into 5. This is 582. 582. Clear? So this is 10,000 into 5 minus 5,000 into 5/2. Clear? This is at C. BM at C. BM at C is equal to 37,500. 37,500 Newton meter. At C, at A, 0. BM at A is equal to 0. Now draw the figure. Clear? A, C, D, B, E. Now at A, E0, E0, at B, minus 5000 Newton meter. This is minus 5000 Newton meter. At D, 30,000 plus 30,000 Newton meter. At C, 37,500 Newton meter. This is 37,000 Newton meter. At A, 0. Clear? Clear? Again I am telling you, BM at E 0, 0. At B, minus 5000 Newton meter. At C, plus 30,000 Newton meter. At D, plus 37,500 Newton meter. At A, 0. Clear? Draw all the figures. Clear? So, from A to C, parabolic. This A to C, parabolic. From B to E to B, parabolic. Clear? B. It B, minus 5000 Newton meter. Clear? C to D straight line and D to B also straight line. Because this is first degree of x. So this is straight line, this is straight line. Clear? This is point P. This point P where the bending mode changes its sign. Now we'll find out the value of P. Clear? This is shear flow diagram, BM diagram. This is negative value, this is positive value. Clear? Similarly, this is positive value, this is negative value, this is positive value. Clear? So at point C, the BM is maximum, 37,500 Newton meter. At B also, the BM is maximum minus 5,000 Newton meter. This is negative side, this is positive side. This is plus side maximum, this is negative side maximum. Similarly, at a point P, the BM changes sign. So at this point, the point of contract lies. At this point, BM is 0. This point P. P. Clear? At this point, the BM is 0. We'll find out the value of Y. Suppose this is Y. Suppose this value is Y. At point P, this is point P. This point, the bending mode changes sign. So this point P is called point of contracture. At this point, the BM is 0. I'll find out the distance of Y. Clear? Now from figure, now BM at P is 0. Clear? This is Y. So RB into Y minus RB into Y minus 4,000 into Y plus 2.5 2 is equal to 0. What is RB? 11,000 Newton. This is 11,000 into Y minus 4,000 into Y plus 2.520. Clear? So solving, you will get Y is equal to 0.71428. Y is equal to 0.7148 meter. Clear? This point Y, the distance of P from B. Clear? This is a problem 66. Next class, I will start bending stresses in beam. Or I will do some problems regarding this point of contracture, or I will start bending stresses in beam. Thank you. Please make, like, share, subscribe to all our videos. Thank you.